Hello and welcome to today's Regcast on this unseasonably sunny day in October. Today we are going to be talking about big data. But before we do that, let's do some introductions and some housekeeping. I am your host, Lucy Sherrif. With me today we have Michael from Microsoft. Michael, hello. How are you doing?
Hello. Very well. Trying not to perspire too much on such a beautiful day.
And we have Peter Elleby from Hydra, who is our resident expert on all things big and data and crunchy. Peter, how are you doing?
Very well. Hydra water, just what we need
Hydra
today.
water. And last but by no means least, Dale Vile from Freeform Dynamics will be joining to tell us what you guys already know, what you're telling us, and how that all fits together. So the first thing we need to do is you will notice above my head, somewhere, there are some buttons. Those buttons, in here we can't see them, but out there you can. Those buttons are to remember, ask us questions. We can't think of all the good questions to ask. You guys are the ones who know the good questions to ask. And these guys are the guys who know how to answer the questions that you know you want to ask. So click on the button, ask us some questions, and we will answer as many as we can. Unless you ask us for the root of 27, in which case, no dice. So that's who we are today. And let's move along swiftly and say, right, what are we here to do? We're here to find out about big data. We've talked about cloud in the past. This is a little bit different. Dale, do you want to kind of pick up on that and see where we're going?
Well, we've done quite a bit of webcasting around different aspects of the cloud over the last probably year or so, actually, with the register audience. And just to orientate us today, there's kind of two ways of thinking about this. One of them is just where are we in the whole stack. So if we think of cloud as basically being about infrastructure as a service at the bottom, where you're basically using hosted resources and doing what you want with them in a very kind of manual way. At the other extreme, you've got hosted applications, software as a service, as many people call them. Where we are today is we're kind of the bit in the middle. We're talking about application platforms, platforms that are in the cloud that allow you to develop and deploy different kinds of applications. Now, we have actually talked about platform as a service before, but it's been mostly around ease of development and how, when we have a bespoke application developed for the cloud, it's easy to make it outward-facing. London Borough of Lewisham, for instance, gave us some good examples a little while ago around that. Today, though, we're talking about a different kind of application, the kind of stuff that really does take advantage of scalability and elasticity, which are two buzzwords that we hear a lot of. Exactly.
Those keywords,
so this is the heavy stuff we're talking about today.
Okay, so do you want to, Peter, do you want to kick off and say, who is Hydra? Why are you the experts? Why do you know so much about big data?
It's Hydra. It's the product arm of a big agency, digital marketing agency in London, called Greenlight Search. And what we're trying to do is we're basically in-house. We have tried to support our customers across multiple channels for a very long time, and we try to find ways of doing that in an effective way internally. And as we were doing that, we found out that actually there was a very big market doing it externally as well. So what we wanted to do was to take the infrastructure, what we had built internally, and actually think about how could we turn it into a product that we could make available to a very big market. And I think because of what we're trying to do and the space we're in, there's actually a lot of lessons to be learned.
Okay. Do you? So what is it that you do? Can you give us a little bit of the tech?
Yeah. There's a fairly decent slide that shows us what it is we're trying to do. We're basically working across multiple channels, traditional marketing channels, in a digital sense. So the ones you have is natural search, which means organic as well. Basically means how you rank naturally for keywords on the major search engines, being Google or Bing.
Do you want to go back one slide, Lucy? I think we've inadvertently gone.
Oh.
Or
did I not go far enough?
Oh, maybe we didn't go far enough.
There we are.
There we go. That's the
there
one.
we are.
Perfect.
Yeah.
So we have natural search, as I said, which is the way you normally rank. There's page search, where you actually pay to have your adverts kind of occurring with the search results. And then you've got social media, which is obviously new things, where you've got Twitter, you've got Facebook, and you've got all sorts of blocking means that you actually what we're really interested in is how are our brands positioned across all of these digital channels. And what we also have is we have two other sources of information. We got on-site analytics, which is what happens on your website when people arrive at it, where do they go, how long time do they spend at various parts of it. And then you've got cross-site analytics, which is how websites link together on the internet. And all of that information we have to take and put into one platform and use it in a sensible way in order to achieve things for our customers. So what do they want to achieve? Let's say you are a news kind of source of news. You really would like to know, if I'm going to put a story out, how likely is that story to be picked up by a large number of people? Because you want to drive people to get to your site. So let's say Natalie Portman gives birth, which she did a couple of months ago, and you think, what should I do with my news article? So one of our customers thought, we write a lovely article. The headline is, Natalie Portman, Baby Joy. Sounds wonderful, isn't it? Sad thing is, that's not the way people were speaking about it on Twitter, because everybody said Natalie Portman birth. So if this customer had used Natalie Portman birth rather than Baby Joy, they would have had a lot more hits when it came to kind of natural, organic search.
So it's picking up on the signals, picking up on the stuff that everybody's talking about.
Exactly.
In real life.
Exactly. Phrase
but
marketing.
Also how they're phrasing it as opposed to
exactly
phrase the same thing in different ways.
You can phrase it in different way. You can do it positive and negative. Assume you have a marketing campaign. You're going to pay to advertise a particular product. And you think, oh yeah, that's a very good product. But actually, people are talking about that product in a very negative way. Yeah. So if you could go and analyze the sentiment about a product, you could use that in order to determine how much money should I spend on actually promoting a particular product. So that's the kind of thing we want to do. And what's the key to it is we really want to take all of that data, allow people to organize it, analyze it, and optimize. And with optimize, we're really talking about predictive analytics. If we were to invest in this, what would the effect be? If we had a campaign in this particular way, what would the effect be? That's what we're trying to do.
Okay. Dale, is this stuff that people are talking about? Is this something that kind of you're picking up at the moment?
Yeah, if you kind of look, if you sort of look at what Peter was saying from a generic point of view, I mean, we're talking about applications or problem areas where you've maybe got a lot of unstructured data, textual information, you've got a lot of complex relationships between different things out there, and you're pulling that stuff together and trying to make sense of it and make decisions off the back of it. Well, actually, there are a lot of scenarios like that. Michael and I were talking about this earlier on in different industries. I mean, Michael, what are some of the industries that you've seen this occurring in?
Essentially, you're processing masses and masses of data to get to the essential insight, that essential piece of data that says, should we do this or not? And so that idea of processing data to come to a piece of insight or to a decision is very, very common in the insurance industry, where you're looking at actuarial calculations. You'll go into the finance. The major banks will be looking at risk analytics. There's many different industries where that idea of processing masses of data to get to that one key insight is quite a common business problem. And it's not that dissimilar to what's going on here. It was interesting hearing Peter talking about processing all that data to essentially understand what people are talking about. The complexity of that comes down to that classic big data problem.
So we've talked about big data quite a lot. We've mentioned big data a lot, but right down to the nitty-gritty, what is big data? I mean, if you really want to know, what are we dealing with here?
This is going to be interesting. Definitions.
Brace yourselves.
The classic definition has 3 dimensions to it, and I think it was Forrester who brought it out originally. They basically had the 3 dimensions. One is volume, which is basically, the amount of data you want to store, and really to try and say there's 2 aspects to it, which I think is quite an interesting point to a twist to it. It's not only about storage of data, it's actually about being able to analyze that data as well. And for us, it's really quite essential, because when we talk about volume, it has a lot to do with the kind of the complexity of the algorithms we use to process data. So if you think about it, we might on a very large website have perhaps 10 million pages, and we have perhaps 100,000 keywords. But if you're going to look, kind of find out which of those 100,000 keywords are best represented by a particular page on a website, you're not going to do that by just taking the combinations of the 2 the cross product of the two numbers, because this is too big. It would take you months and months and months to do it. So you have to be a lot smarter about how you actually process and organize the data. So that's the first part of it. The second they talk about is velocity, which is the speed at which data gets generated. Obviously, you know how many tweets that occur on a particular day, so you can imagine the data in our space is really changing very, very rapidly. Obviously, there's some limits to how quickly you can change your websites today, but even that is starting to become more and more frequent, the changes that actually occur. So that's the rate at which things come in, and then the rate at which you have to make decisions. As I said, the example I gave with this news story, a news story might be interested in the market for perhaps a day, 2 days. That's where you're going to get your peak traffic. So it's very, very important that you make the decisions quickly, discover what's happening, and actually act on it. And the third dimension is variety. You're dealing with a lot of data that is in a much more unstructured form than you traditionally would do with databases. When we talk about ETL processes in the past, that's very structured data, comes in, gets changed slightly in form, and then put into another form. That's about it. But we're really dealing here with data that is very, very different in this form, in its kind of, I would say, variety.
Out of curiosity, you just spoke of processing all the Twitter feeds. That's a massive amount of data. If you're processing all those Twitter feeds, which might be gigabytes or petabytes even of data, how much do you actually retain out of that at the end of the day?
The point is you don't retain it. You actually know what you're going to look for to a certain extent in those. You're looking for signals. You're doing pattern recognition. You already know what you're going to look for in the tweets. And it just doesn't make sense to take all of it in.
Okay.
We actually buy in from companies who have got access to the complete, set of tweets that actually occur. We actually buy for them, and we have interfaces by which we can go and take exactly what is necessary for us.
I think that's one of the big differences between what people are calling now big data and traditional business intelligence or analytics. I mean, you mentioned ETL. I mean, really, in the old days, it was a case of you extract information, the E-bit from the source, you transform it, i.e. you get it into a form that you can suck it into your data warehouse in, you then actually load it, then you go through a whole bunch of analysis, and I mean, quite often this can take days, weeks to do this kind of stuff in a typical BI environment. And ultimately, you get to some kind of insight. But the implication is that you're actually loading everything in the first place. And I think that the big thing about big data is the concept of signal to noise is different. So you take something like a Twitter feed, but lots of different feeds. Actually, you're kind of looking for the proverbial needle in a haystack. There's some goodness in there somewhere. You just don't know necessarily what it is. You can't load everything into your warehouse and then mess around with it. So you have to actually process it as you're actually pulling it in. Yes. If I understood that correctly?
Yes, exactly.
And that's a pretty big difference to the traditional data warehousing kind of approach.
Well, to stretch your analogy, perhaps the breaking point isn't the difference that in traditional data warehousing, you know what the needle is.
Yes.
You've got to sense what the structure is, whereas in your big data problem, you're fishing for something. There's something like a needle out there, but it may in fact be a needle, a knitting needle, or a
pin.
A pin, yeah.
Yeah.
I have stretched the analogy of breaking up.
No, but I think that's the point. I mean, we were talking earlier on about traditionally when we've thought of business intelligence and analytics, it's been all about you form a hypothesis and you go and test it, so you know what you're trying to test, or at least you're working some kind of model. How have my sales changed from this quarter to between last quarter and this quarter? I mean, here, as you say, you don't necessarily know what you're looking for, and it might actually be a pretty small element of this huge data volume that you're.
And really, if you look at our particular application, if you're having paid search, is a perfect example of that. You're often doing paid search campaigns just in order to learn what's actually happening out in the real world. So you're actually conducting experiments on the fly in order to learn from the data and see what you can actually do from it, which is another kind of, it's a different world in the sense that you can actually go and affect the data that gets collected.
But these are things, quite frankly, that a lot of people just wouldn't even have attempted before because you don't have the horsepower and the management capability to do it. So, there's a whole bunch of data which every organisation has accumulated and has access to that never ever gets the goodness extracted from it because we haven't had the means to do it.
Yeah.
But isn't the implication of what you're saying that big data is really nothing new? The big data's always been there.
Yeah.
The difference is that we're now starting to look at it.
I think there's an element of the big data's always been there, but I think we are seeing more of it, especially with social media and some of the things that Peter was mentioning. So it is, we are getting more and more sources of information, aren't we? I guess.
Well, you can see on the slide, in fact, here, information created, available storage.
Yeah.
Something of a mismatch.
Yeah, I got this from The Economist, and I thought it was quite fun because it's 3 years ago, actually, and I wonder whether the rates are roughly correct. An exabyte, just for everybody's benefit, is actually 1 million terabytes. So even the biggest storage vendor today probably would have some difficulties representing it. And the point is here in this slide, which I think is actually made very well. The speed at which the volume that is available to store information is not going to be able to keep up with the amount of information that gets generated.
So you can't keep it all.
You can't keep it all,
hang on to
and that's
it.
exactly the point that Dale made. We have to get to a point where we are more smart about the information we actually store. It has to be a kind of statistically representative sample that we actually store of the information, or process means at least of doing things.
So
And it's
no
not
more putting things in a shoebox and keeping it under your bed. That's not going to work.
I don't think that's going to work.
No, well, that's too bad. That was my strategy.
And it's not just a case of whether you have the storage devices, the technology to actually do this. I mean, if you do start trying to store those kind of volumes, you've got a huge management problem on your hands, haven't you?
Even if you've got the data, how do you learn anything from it? I saw a fascinating statistic, I'm not sure I'm entirely convinced of it, but it claimed that this year the human race will create approximately 1 zettabyte of data, 1.2 zettabytes, which is more information than has been created in all of human history prior to that. A zettabyte being 1,000 exabytes, which makes it 1 million petabytes. I'm getting my Greek prefixes confused. But
Has anybody had enough coffee to deal with these numbers? Because I don't think I have.
that's a huge amount of information. So it goes back to your points of how do you actually
Although
process
we
that.
have to ask whether a lot of the marketing blocks are actually information. But that's a different story, isn't it?
We won't go onto YouTube.
YouTube is valuable. Lolcats, come on. So it's not just about the volumes. It's about how you process and handle that information. What you're doing with that when it comes in. Are you doing this in-house?
We're not doing it in-house for a very good reason. And it has to do with cost. And I think it's something that a lot of people don't really appreciate today. But this has to do with the fact that data doesn't flow at a uniform rate. Yeah, if a traditional internet site you look at today, if you look at the demand that occurred during the day, are vastly different. Not surprisingly, at lunchtime you'd see traffic peak, and at 5 o'clock, funny enough, it peaks as well. And by 9 o'clock, people must be doing something else. And I presume certain websites might do later at night, but that's a different story. But the thing is, there's a very big difference between the peak rates and the average rate you actually see on a website. And when you have to build things to process this, you actually have to take that into account, because you have to dimension your facilities not on the basis of the average, but actually in terms of the peak loads. Okay. So if you have your own facilities and we see that in-house and you're going to handle this in an effective and timely manner, it gets very, very expensive, because you end up perhaps buying 10 times the amount of equipment you actually need just in order to be able to handle your peak loads.
Yeah, this is a kind of a very, very big version of what happens when Stephen Fry links to something on Twitter.
Yes.
He links to it and it falls down.
Yeah.
Because the scalability is
The scalability is a real issue. And it's a very, very costly issue that you have to deal when you're dealing with big data. And I think that's going to limit unless, and obviously we're talking about the cloud here, unless you find a cloud solution to this, this is going to be a real limitation to what people can actually do in terms of big data.
Okay, I'll just take a moment. We've got a question coming in. It says, most of this data is rubbish though, isn't it? Particularly in social media. We wouldn't want to store it even if it were possible, so how do you analyse it in real or near real time?
You do it by looking for patterns in the data, and by doing sentiment analysis. So you're actually trying to extract out of the data that comes in what makes sense and what doesn't make sense. And you're trying, obviously, there's very, very big difference in the quality of the tweets, and there's obviously on Facebook. So you can actually see as well, you know something about the profile of the people who are tweeting. You actually, from that, you can say as well whether the quality of the data is going to be good or not.
That question actually sums up a big part of what big data is all about, to be honest. So that's a pretty good question.
And then another question quickly here. An admission that people can no longer deal with all of this info, and that surely they want the machines to make the decisions for us. Is this about handing over to computers?
I don't.
Are we surrendering? Do we give in?
There was a very famous quote that I still laugh at, which is it's a little story with artificial intelligence, and I always like this. The kind of what is the an Irishman was kind of asked what was the most intelligent device that was ever being created, and he said the only truly intelligent device that was ever created was the thermos flask. Because if you put something hot into it, it would know to keep it hot. If you put something cold into it, it would know to keep it cold.
Okay.
And actually, I think that shows you the limitation of artificial intelligence, if anything. I think there's always things we can do and things we can add to it, but ourselves. But I think we have to realize that artificial intelligence as a tool is about providing means for doing things that we can't do very easily ourselves, for extracting additional information out in a more kind of get the visibility and understanding of what the data is, so that we can make better decisions in a faster way.
Crunching through the stuff that we can't.
Yes.
That we can't.
Of finding the exceptions, perhaps, the exception that breaks the rule that is actually are worth for us to go and look at.
Yeah, I mean, let's not get carried away. This isn't about machines making all the decisions. This is about actually as a whole. Well, as the questioner said a few minutes ago, you got a shed load of data here, most of which is rubbish, but you have got some good stuff in it. You would never in a million years even attempt to try and find the good stuff in those kind of volumes. And what we're talking about here is actually applying intelligence in inverted commas. We're basically pattern matching and various techniques and algorithms to actually identify the useful bits and pieces. You then act on those in the same way as you would any other form of intelligence. It's just that we're dealing with a different kind of source here.
Yes.
Okay.
And that, I think, really nicely leads us over to the third point, which is the different types, the variety of data you have to deal with. You know, website data, hierarchical data, networks really of information linked, and, you know, you need to be able to go and be able to process that, which is a notoriously hard thing to do in a traditional database. You know, I don't know how many papers I read when I did research on relational databases about doing transitive closures in relational databases. It's just not something you can do very easily, and that really works. Documents, semantic analysis, going in, looking at text, although you can recognize components of text actually to see how they fit together, whether it's a positive or negative sentiment, is things that are fairly difficult to do.
There's an interesting concept in here, isn't there, which is taking unstructured data, or what we think of as unstructured text, and actually deriving structured output from it.
Yes. That's exactly what you're trying to do. You're trying, to find the key phrases in it, how they hang together, whether they're used together, in what, you know, whether there's any cross-relationship between things and so on.
Yeah, so at the risk of being boring, you might have a document this big, and you might end up with a couple of records at the end of it which summarises what is important about that document.
That's actually what you want to do.
Exactly.
If you're successful, you actually end up with a very few keywords that will.
And so you don't store this much; you store this much.
Exactly. We have had some fun examples where we, on some of our sites, where we have actually tried to, for fun, store the information, and you're talking so much data, you know, that it's just ridiculous, and there's absolutely no value to it.
To what extent, though, can your systems actually understand the meaning of the document you're parsing, and to what extent is it just pattern matching?
You actually do very detailed analysis on the basis of what type of words it is you're looking at and everything else. So you do actually have quite a decent understanding of how sentences are built, and you really do understand quite a bit of it. But whether it's a deep understanding is different. It is, I would say, very sophisticated pattern matching at the end of the day.
So basically what you've got is a big pool of infinite monkeys, and you're looking for Romeo and Juliet. Isn't that right?
Yeah, that's pretty good.
Yeah?
Yeah, that would be good, yeah.
And be careful, because you might end up with Coronation Street if your semantic analysis isn't good enough.
Brilliant.
All right, let's just move on to this next slide quickly. Not that one. Where am I going? Backwards. Sorry. Here we go.
Okay.
People used to say that information is power, but that is no longer the case. It is analysis of the data and use of the data, digging into it. That is the power.
Yeah,
Who said this?
I put it's from Martin Sorrell, and if you noticed it, I put it at the background is a view from a plane, the 20,000-foot view, which is a little pond here. But in our business, Martin Sorrell is like one of the leaders, and obviously, I think this quote is actually good because it's trying to describe something. But I'm not sure it's necessarily what Martin Sorrell meant with it, but let's leave it at that and say that really, but to me, what this quote means is that beforehand, it was very much about you knew exactly what it was you were going to go and look for. Yeah, so you could actually take the data, translate it into a form that made it very, very easy to go and get the answer to what it was you were looking at. Yeah, in traditional ETL, business intelligence, you built cubes because you knew exactly how things were going to break down and how you were going to go and look at things. Today, that's actually different because we have a whole set of algorithms that we have to apply in an intelligent fashion in order to extract valuable information. At least that's what we have in our space. And it's that makes the difference. So it's the analysis part of it that's become really, really important. It's the, what you say, unstructured analysis, perhaps, that's become really important.
The machine learning, perhaps.
Machine learning.
Hypothesis testing. Yeah.
Well, what's interesting about this as well is going back to one of the questions that talked about machines taking over the world and stuff. This is kind of reversing things a little bit. So it's interesting when you look at who's involved in analysis and decision-making in organisations. Because, in the old days, you would need a whole bunch of intelligence and business experience up front to design your models. But then, to be frank, you could actually have not much more than administrators actually going through and turning a handle and coming out with pretty charts and graphs and, sending those to the board as information updates. Well, actually, this is dependent on the people doing the analysis actually being able to understand what's significant and what's not in business terms. So it's a different way of thinking, and I think this is going to challenge some of the existing ways in which people are set up from an analysis and reporting point of view. Having a pool of people who do nothing but number crunch and then pass charts over to a bunch of other people on a monthly basis, I don't think that's really going to be the way we do things in the future.
I always think business intelligence was a gross insult to senior managers because if you think about it, it's always presented as the way we have to do it so simple that even the chief executive can understand what this data mean, isn't it? It's kind of, and really, you want to use the experience, the understanding, and what, they might actually know more than anybody else what is strategically important things to look for. And it's that is going to make the difference. But
question for you, Peter. I mean, how does this translate to what you build into your service? I mean, how do your customers, do you give them a console or dashboard or something?
We give them a front end by which they can actually go and analyze and do the analysis. And we have some very interesting technology for doing that in its own right. We talked about it a little bit, but we are using technology that you actually would typically found on trading floors. So we're using heat maps and so on in order to see how things changes, where the things are. And we are doing some very clever structural, hierarchical modeling that actually helps us literally look at the data from a 20,000-foot view. So you can see exactly what's happening on the top level. You can actually understand how they break down and how the signals are coming into that framework. We call it the word bank. It's literally our technology, proprietary technology, that is really trying to do exactly that.
How do customers get on with that? Do they find it quite intuitive, or is there a bit of a learning curve there?
It's absolutely amazing. So obviously, I'm not a salesperson, but I would tell you, we went to one pitch, and the customer had basically their response was, "I've never seen data like this." Yeah. You can even go and look at the tweet from Hydra, and you can find out who it was. But it literally is like that. It's that profound because people are really not used to looking at the data in that fashion and having a starting point for actually understanding what is happening. And it's not, the interesting thing about it is not simplifying it. It is showing that it's a high-level view of the complexities of the business you're actually running.
Yeah. And the reason I ask is because I've heard this story time and time again, not just in this context, but people who've gone down this route of sort of interactive, predictive analytics with a big data sort of infrastructure in place. It changes the way people interact with data. And people start to get enthusiastic about what they have access to, as opposed to, here's another report, let's wade through it and find out the bit that's different between us.
I can give you an example. We had, in one particular case, if you have natural search or paid search specialists, there's a limit to how many keywords you can handle. Yeah? 5,000 keywords is a very big spreadsheet if you're going to kind of try and manage that and try and understand what it's actually doing and which are the important keywords and which are not. You really can't see, the wood for the trees, literally like that. It's a really big problem, and in reality of it is, if you really want to be successful in digital marketing, you need to perhaps expand that to 10, 50, 100 times that number of keywords, and you need to have some means for representing that and analyzing and then distill out what is really important amongst that data set and what's not. And that's really what we're trying to do with the Hydra platform.
Okay, can I interject here with a question from the floor? This is Dave, who says, where does data quality come in? Are we saying that in really big data, any and all attempts to apply quality and cleaning are a waste of time? What about master data management? Sorry if I'm still living in the past.
We're still trying to do that because, as I said, we're trying to get statistical representative data. And that is basically about data cleansing. It's not about, making sure that it's spelled correctly every single way and so on. Obviously, there's still an element of having to do that, but fundamentally, it's kind of raised one level up. So I would say it's much more on a semantic or strategic view of how the data is going to be used. You're trying to cleanse the data, and these algorithms are basically trying to filter out the noise element from the actual valuable data content.
And is there a sense in that what you are doing is sentiment tracking, that there is no such thing as bad data and that it all is reflective of a sentiment in the market, if I could?
Bad data you could get if you had very bad samples.
Yes.
It's obviously a good example. But I think you can extract, for most cases, you would actually get fairly decent signals. It's all about signal to noise, and there will always be a certain element of noise. And you just accept that in the way you process the data. It's just part and parcel of the world. We're not trying to make perfect data. We're trying to make perfect solutions, if you want to.
Well, I've heard some people say as well, with this kind of technology and approach, that it's much better to get to an 80% accurate answer very, very quickly than wait a month to get something which is 90 or 95% accurate. And I think there's a lot of that. It is a different way of thinking. So, I mean, you do need to pay attention and sanity check what you're doing from a quality perspective, but you wouldn't necessarily go down the route of applying the same level of rigour, because the very assumption is that it's all fast-moving. So by the time you've done that, the world's moved on. And I think that's an important principle.
Is there a feedback loop in what you do? Does your system make decisions about where to place keywords or all that kind of stuff on the basis of what it learns in the market?
Yeah, we actually have feedbacks from analytics, so we would see where the sources come from to a particular website and how people go on and buy. So we could do some attribution analysis as well. So we can actually tie all the way back to what people actually buy, to where they saw things originally, where they come from, how it's talked about. So we can actually get a very good impression of that as well. So obviously, whenever we do and make recommendations, we actually monitor as well to see whether they actually play out the way our customers would expect.
Okay.
All right, we've got quite a few questions coming in now, basically saying, this is great, this is all very interesting, but what about the business case? What are you running this analytics on exactly? You say the cloud, what is it, says Martin. And people are saying, how much of a saving running this in the cloud compared to self-hosting? Since this involves data storage costs, how do you spend your time? Breakdown in terms of compute cost versus data storage costs and uploads. So I suppose it's probably quite a good time to move ourselves along to the next bit.
Yeah, why are we talking about?
Why are we in the cloud?
Yeah.
Yeah.
So looking at it from our perspective, there's really three business drivers that are causing us to go to the cloud. The first is very simple, the infrastructure cost. Yeah. What
this
it
is
costs.
Your big peak load graph here, isn't
peak
it?
load, kind of large amount of data sources. You have to do all of this in-house. You have to get all the feeds, bandwidth, and you have to process it. I know what it cost us to do it internally in Greenlight, and it was a very big number, a scary number, I would say. And obviously there's a lot of people who would want to, if we could share that across a large number of people, it would be very, very beneficial. So that's the first thing. Deployment cost, the cost of actually deploying the software, maintaining it. We have our own, we we used to have our own data center as well. And, that cost a lot of money running those and kind of making sure things get updated and new releases to the underlying software. You actually end up having to have dedicated people to do it. We had 2 database engineers, literally, and upgrades and backups and everything else. It becomes very, very expensive to do that. And the last one is Hydra. We're a small technology company, a startup really, and we simply can't afford to go out and spend millions and millions on investment in hardware when we can actually go and get it in the cloud, or we can go and get it from somebody else at a fraction of the cost and as we need it. There's just not any sensible business case. Anybody who has a small company who's going to do this, I can't see how you would go past your venture backers by saying, and then we need to invest 3.5 million in hardware that's going to sit in empty, 80% of the time in a data center in the City of London. It's just not going to.
It's actually not just a small company problem. I mean, I've spoken to quite a few people now who have put essentially sort of scale out big data type architectures in their own data center environment, and then have had very hard questions asked of them when it becomes clear that it's only maybe 5% utilised. The whole idea of these things is to run something which took hours or maybe even days before in a few seconds or minutes, but you're not doing that continuously, so the thing is sitting there idling. And
gathering dust.
That there's a limit to how far you are going to be able to utilise it.
Well, Peter, I'm curious, for your typical customer, how many times a month, hypothetically, would they perform this analysis? Is it something that goes on all the time?
It goes on all the time.
Okay.
It really does. But obviously at different times, At the moment, all of our customers are UK-based, except for one case. But actually, as you go abroad, it would be much more of a constant load. But then you're also likely to have it in different data centers.
Yeah. Presumably there's a lot of peakiness to this, a big news event or a launch campaign or anything could treat. Yeah,
there is. And,
Natalie Portman having a baby.
Very important, yes.
Absolutely,
for some people.
Don't forget that.
Yeah, no, there is peakiness. Obviously, the traffic volumes change rapidly during the day, and then you get real peaks. And and there's kind of public holidays as well, where it's even more, and you get all of these things that actually play into it. So you have a very, very large variability.
So, I mean, we could labour this point, but it's not rocket science, basically. I mean, if you were to build this thing in-house and have it sitting there, not doing very much for most of the time, versus sticking it in the cloud and then just grabbing resources as you need it, still with these peaks, pretty obvious what the cost case is going to be based on.
It's a no-brainer, really.
Yeah.
So, why Azure? Michael would love us to say why Azure.
The allure of Azure,
The allure.
With the weather being the way it is, kind of, there's some nice connotations to it, isn't it? The beautiful sea and kind of calmness.
So you chose it because it's...
That was about the depth of our analysis. No, when we were looking at this at first, what we were really keen on, we wanted a complete platform rather than infrastructure. And there is the terminology that's used is IaaS and PaaS. And we really wanted to buy a platform rather than, infrastructure as a service. And I like to laugh a bit at this, because I think PaaS is a terrible term, because whenever I go to our CEO and tell him about PaaS, I can see his eyes kind of, he always think of it as panacea.
It's the double A.
Panacea as a service rather than a platform. It solves all the problems of the world and a little bit more than that. So, no, but in all seriousness, we really wanted a platform that could help us. And we did some evaluations as well of one of the typical IaaS players, and we just found that the cost of actually doing it and what we had to think out in terms of backup strategies and everything else, it was just too much. We would have a very large percentage of our total people just looking at that side of it, and it was simply not cost effective to do that. So we wanted to go one step up the platform stack. The second point was we really chose Microsoft because they were a trusted partner. We are Microsoft partners, so there should be no secret about that. And it was an obvious choice for that reason as well. And the third was we actually had a lot of .NET development in-house, so it was a natural extension of what we did beforehand, and the Azure platform is very good like that. It's actually a very good starting point for your people with your existing skills and take it from there and kind of get them onto the cloud environment. So that was the reason why we chose them, the three main reasons.
Now, one of the things that comes up again and again, I'm sure you'll back me up on this, Dale, that people are concerned when people start talking about the cloud. IT pros are going, but what about me? What about my job? What am I going to do? Is there still a role for the IT professional when we're shipping all this stuff out to the cloud, or are we going to live in a world where everybody has?
I think there's different roles.
Yeah.
There's a whole set of different kind of jobs being created by what we're doing. This is about analytics of very big data. There's a whole number of people with those skills that are going to be in serious demand. If you look at the projections for it really is. This is going to grow, and there's really very few people currently available to work in that space. Is it going to take away some of the jobs from the people who are just looking after the infrastructure in the data center? Yes, I think it will.
Yeah.
But, again, I have to look at this. If I wear the green light hat, it's very, very difficult to find top-grade people who can actually run data centers and infrastructures and everything else. And I actually would prefer not to have that headache of doing that myself and knowing that somebody else takes care of that and actually has got the right people to deliver that service in a professional manner and a cost-effective manner.
Dale, is there something that you kind of get a bit of a view on with the work that you do?
A lot of views,
industry.
and Reg Reader's been very vocal on this whole matter over the last year or two. I think I hear a lot talked about, which kind of is the equivalent of saying, let's wave a magic wand, let's put all history to do with IT behind us, and everything is now in the cloud. And realistically, that's not the world we live in. Okay, so the reality is that apart from arguably some small organisations that can do this wholesale, most people are going to be having to get their in-house infrastructure working together with their with anything that they work with in a hosted sense. Whatever people say, there is still a hell of a lot of bespoke application development takes place out there, and that's not going to stop.
Well, that's what you guys are doing, isn't it?
Exactly, and whether it's in-house, whether it's systems integrators or service providers like Peter. So actually, in most respects, you might get away with a few less systems admins that do routine patching and stuff, but they're not going to go away completely because you're still probably going to have an installation in-house. And things like architecture, security policy management, data protection, all these kind of things actually become more complex when you start blending in-house and cloud architecture. So, some skill sets become even more important there at the moment. So, it's just a bunch of tosh.
So you're not going to be out of jobs?
I think it goes down to this wonderful terminology of Peter's of panacea as a solution. And that's not what PaaS is. It's a platform you can build on. And if you're going to build stuff on it, you need architects and people to do that work.
I actually agree that I think there's more need for good architects than ever was.
Yes. Yeah, absolutely. And in fact, some of the horror stories that we hear from Reg Readers and just generally out and about are when people have just thrown stuff into a cloud environment without really thinking about what they're doing and how it's all going to hang together. And a number of people that have done small-scale pilots, proved the concept, and then just scaled it up without actually revisiting the architect.
It's frightening, isn't it?
You can run into as many problems there as you can with it, on-premise.
I'm doing the same thing. I think people come and say, oh, yeah, we can do it. Yeah, let's just get the platform in-house. If you look the way Azure is built, you can kind of run it as an in-house platform. You think, oh, yeah, really easy. I'll just do kind of almost just a little bit of recompiling and I'll have my solution completely working. And then they deploy it out and the scale just tiny and then everything falls apart. So, yeah, you see that.
So one question for you, though, Peter. You've mentioned you can reuse a lot of .NET development skills, etc. But if you were to take a .NET developer, what needs to change for them? Do they need to think in a different way when they're developing this environment?
Yes, they need to think in a completely different way because you are actually using a platform in order to provide a service on top of it, also for you internally. So we all know that there's new frameworks that are being developed, such as the MapReduce framework from Google. Hadoop is the public source version of it. And really, if you go and look at these offerings, you can actually see that they are really parallel processing frameworks. It's a way of organizing your data, of being able to do things in parallel, of architecting the underlying infrastructure in such a way that you can exchange data within that framework. So it very much becomes, that's really what you have to do and what you have to architect things for. So you just can't just take your standard .NET application. You actually have to start thinking about the problem you're trying to solve in a fundamentally different way, in a way that's actually tied to what the platform that is available to you provide. And I think that that's a key thing that you're really going to see. There's going to be, you have to think a lot more about how is the application actually going to work. What kind of data, how's your data going to be stored, how are you going to do the synchronization between the different parts of the application.
Does Microsoft have any sort of, what does Microsoft have in place to help with this kind of reorientation of development?
Well, we've got courses and white papers to explain that difference. But if I can come back to what Peter just said, if I've interpreted what you said correctly, you said something like the technology, the tools are the same, but the way in which you use them is slightly different because you're now in this cloud-based, you're now in this parallel environment. Is that fair?
That's exactly right. You've got a whole very rich fabric of resources you can take advantage of. So you really have to structure your application in a way that allows that to take place.
Okay. So to your point, what Microsoft can do to help people make that transition from perhaps working in a very single-threaded kind of world, moving into a multi-threaded, multi-tenanted kind of world. And we're not the only people offering this guidance, but we have guidance and white papers and courses to help people make that transition.
And there's a question that came in, actually, that... You okay, Luke? Have that one.
I swallowed my lungs.
There was a question that came in which said, Azure seems to be a strange choice for this kind of application. I mean, shouldn't you be using Hadoop? And
well, we have built our own process scheduler on top of it. I think there's a massive misunderstanding of what Hadoop is. You go and look at it, and actually it's just a very, very simple parallel processing framework, and it's nothing else. And, there's all sorts of other clever things you can do and that we've had to do, and I don't think that in any way, shape or form actually fulfills what we have had to do. We have had to build our own process scheduling there, and we have a lot of expertise in that space. And I think, it's probably a good start for some people, but it doesn't really give us, or didn't give us, what we really needed to do.
And if I could add, Hadoop does run on Azure. Azure is just an operating system at the end of the day for stuff that runs out there in the cloud. So you could run MapReduce on it, you could run anything on it if you wanted to.
Yeah, I've heard a few people... Hadoop has caught a lot of people's imaginations, hasn't it? It's one of those things that people like to talk about. It's quite trendy, especially because it's got open source connotations, etc. But I've heard a lot of people say, well, actually, the enterprise readiness is something that you have to add. I mean, even simple things like security, I understand, are something that you need to sort of pay attention to.
I just don't think... There's obviously companies who are trying to take and make that answer some of these more enterprise things. I can't remember the name of... There's a couple of companies that are doing it, but it's not a panacea. It's just a tool, like a library, if you want, that you can use, and it's a good building foundation.
So you already had those skills and expertise, so it was easier for you to build something which was fit for purpose. But I guess for a lot of people, something like Hadoop might be a reasonable starting point.
I think it would be a very good starting point because it's well documented, it's publicly available, and so on.
Okay, now nothing is without challenge, as you can hear. But if we can just quickly move on to the next, to the pretty much second to last slide, actually. What challenges have you faced, even with Azure and its shiny, wonderful blueness? That Michael is the Azure.
Well,
what kind of stuff have you come up with?
One is you have to learn, and it is fairly new technology, so you will not have necessarily all the resources available from day one that you would like to have. And I think there's a lot of effort going in to make sure they are available, and it is helping, but we struggle a bit with that. There's two things that you really have to look out for when you're going to go and use Azure in an environment that we have for big data. There's a 50 gigabyte database size limit on SQL Azure, and you really have to be aware of that. You have to, in our case, we basically looked at how we can split our application over multiple databases behind the scenes. So we've had to manage that. You also have to be very careful when you get close to the limits in terms of size of the database. The system will actually, the SQL Azure platform will start throttling you. So the performance of your updates and your reads and everything else from a database actually start going down. So you have to be very, very careful about that, and you have to manage that very carefully. In general as well, throttling at high usage, the way you design your application is very critical. If you get it wrong and you start consuming really, really large amount of resources on the platform, you will get throttled as well. Right. And when that first happens to you, you really are scratching your head and saying, what is causing that? But you will get down to it, and you have to take a step back often and say, how can I architect this differently in order for this not to happen? And I think those are the two major challenges you're faced with.
So did you actually go through a sort of evaluation, proof of concept thing, or did you find these things out as you were
We did
developing?
a proof of concept, and then as we ramped up, we started ramping up with the first customers. We basically had 3 early adopters, which is a fairly sizable company. So when we kind of went live with those, we actually started seeing some of these issues even more. And you obviously have to address them at that point.
Yeah.
I think there's a question quickly from Michael. Why on earth is that 50 gigabit limit in place? And when is it going to be expanded to the real world? And also to everyone who's suggesting I have some Benelin, yes, I'd love some.
The 50 gigabyte limit is something that came with the early design and the early development of Azure. Azure's been in market about 12 months. And as the product is adopted and used, we're seeing changes and new features come into place. We've got a whole new set of new features being announced shortly, and we'll see what comes out of that.
But Peter, you guys have found a way to live with the limit.
You can live with it. You can almost live with anything. We are computer scientists, so we will find a way around anything.
Okay.
I think actually it probably reflects some of the early thinking around Azure as being a general purpose platform for collating lots of smaller footprint applications, and I think maybe big data, genuinely big data, wasn't necessarily conceived as part of the plan to begin with. But as you were saying earlier on, you can work around it. You can set views over multiple
database. We basically split things like a shard across multiple databases.
So you need to take care of it when you're writing data, but when you're reading
it becomes because we can then split the application kind of in a reduce that kind of fashion, so that we kind of read from individual databases and aggregate things up from each.
But it's actually an interesting thing to, or it's an interesting opportunity to underline one of the common misconceptions about big data, which is that big data is always about storing huge volumes of data. It's actually not always that. It can be, but it's as much about, it's mostly about taking in big feeds or high volume feeds and reducing them down, and what you end up with is a manageable, more structured set of...
It's better to say it's about processing lots of data rather than storing lots of data.
So the important thing about Azure is the parallel processing capability. That
exactly.
Yeah.
Okay. So we have got some further reading for you guys. Don't fear the bit.ly. Excuse me. You can click on the button above to download the PowerPoint slides from this morning's presentation. So don't worry about the bit.ly. It's all in there. So there's some further reading for you. You can find out a little bit more about the Hydra project generally. So I think all that remains for me to do is to say thank you very much to our lovely panel of experts coming in and talking to us. Thank you to you all for your very kind thoughts. And my apologies for my extremely strange outburst towards the end there. I will try not to do that again. So there will also be an archived version of today's events available on the web to download. So I think that's big data.
Thanks, Lucy.
Thank you very much, guys. Cheers.